This study investigates how upper-grade elementary school students perceive generative artificial intelligence through the use of an educational chatbot in the classroom. The findings reveal that children form hybrid mental models, combining technological understanding with anthropomorphic interpretations, often viewing the system as a smart friend or teacher. The research indicates that ongoing interaction promotes AI literacy, as students realize that responses depend on their own questions. Despite improvements in their understanding, certain misconceptions regarding the authority and reliability of these systems persist, making pedagogical guidance essential. In conclusion, the source emphasizes that critical thinking and digital literacy do not arise automatically from exposure to technology, but require targeted education regarding its capabilities and limitations. A relevant presentation follows. Welcome. In this slide, we focus on a crucial concept: the malleable mind of the AI native student. The model symbolizes a merge, natural human cognition meeting artificial intelligence. Today's students are AI native. They grow up with this technology as a given. As the text box highlights, our goal in primary education is clear. We must guide students to move from naive interaction, where they simply consume AI-generated answers, to critical generative AI literacy. Our objective is to teach children not just to use AI, but to evaluate, question, and creatively collaborate with these tools right from the start. Let's explore how children's understanding of AI evolves. Initially, students view AI as a mysterious black box or an all-knowing robot. To them, it functions almost like magic. However, as they interact with the technology, their perspective shifts. They start to understand the inner mechanisms and recognize AI's limitations, such as hallucinations. The most important step is developing procedural awareness. They realize that the machine's response depends entirely on their input and human guidance. By learning to ask better questions, students transform AI from a magical robot into a collaborative learning partner. Let's explore how this looks in practice by bringing artificial intelligence into the authentic classroom. Our subjects were upper elementary students, specifically 10 to 11 years old. For our educational intervention, we facilitated sustained, qualitative interactions between these students and a customized educational chatbot. What was our core inquiry? We wanted to map exactly how children dynamically conceptualize these technologies. Our goal was to understand how they build mental models when interacting with opaque, black box generative AI systems, giving us a magnifying glass into their cognitive process. Let's examine how children initially understand artificial intelligence. Prior to sustained interaction, their comprehension relies heavily on what is observable and intuitive. To explain opaque computational processes, young learners draw upon familiar media and daily experiences. This leads to three simplistic models. They view AI as just a robot, as a machine that dispenses answers, much like a vending machine, or as an unexplainable black box that works like magic. These surface-level models rely purely on simplified, functional interpretations. At this early stage, students completely lack an understanding of the underlying computational logic. Let's explore how iterative dialogue refines students' mental models. Through sustained interaction, children move beyond simple robotic interpretations. Instead, they develop a practical understanding of how their own actions shape the system's outputs. First, they begin recognizing the underlying structure. They realize that interacting with AI is not magic, but a logical process of information retrieval. Second, they discover the immense power of phrasing. They understand that their initial prompt, exactly how a question is asked, directly dictates the final, tailored answer they receive. Conceptual change is a process, not an immediate event. As students develop their understanding of artificial intelligence, they often hold conflicting ideas simultaneously. While they begin to grasp the technological explanation, that AI responds to specific prompts, a sophisticated view, they continue to hold on to intuitive personified beliefs, like thinking of AI as a smart friend. These emerging technical concepts don't simply replace the old, simplistic models. Rather, both perspectives coexist within their developing mental model. This transitional stage is crucial as students move toward critical literacy. We must view the chatbot not merely as a tool for task completion, but as a dynamic environment for conceptual exploration. In education, we are balancing two distinct approaches. On one side, there is learning with AI, which involves using it for completing tasks, generating ideas, and building operational competence. However, there is another, equally critical side, learning about AI. Here, the technology itself becomes the conceptual object of inquiry. We must encourage students to actively question how the system functions, what it actually knows, and the true nature of its responses. There is a hidden danger in how seamlessly these systems communicate. The conversational fluency of artificial intelligence creates a dangerous illusion of expertise. Children naturally use anthropomorphic reasoning to understand new technology. When they interact with a friendly, chatty interface, they immediately build trust, equating the system with a smart teacher-like figure. However, this leads to inflated perceptions of authority and reliability. The critical warning here is that when students are blinded by this conversational eloquence, they consistently fail to recognize the probabilistic nature of generative AI, missing its potential flaws. We must recognize a crucial limitation. Technological exposure alone cannot erase persistent misconceptions. While using chatbots certainly drives curiosity and sparks conceptual exploration, simply interacting with the tool is not enough. There's a missing puzzle piece. That essential missing piece is critical understanding. If students' foundational ideas about artificial intelligence remain fragmented or heavily anthropomorphic, meaning they still treat the machine like a human, they will be entirely unable to critically evaluate the outputs they receive from these systems. Let's conclude with the most important element, the educator. Teachers must serve as the cognitive mediators of artificial intelligence. The educational value of AI doesn't come from merely having the technology in the room. It depends entirely on guided inquiry. The teacher is the one who hands the student that missing puzzle piece of critical understanding. To achieve this, the educator's role is threefold. First, to explicitly identify the system's limitations. Second, to scaffold questioning and verification. And finally, to consistently push students far beyond surface-level interpretations. Pedagogical mediation actively shifts the entire AI learning paradigm. Let's compare two distinct approaches. Without guidance, technology acts as an autonomous instructional replacement. Students perceive AI as an authoritative expert, blindly accepting its outputs as absolute truth. Ultimately, this leads to dangerous technological overdependence. Conversely, with proper pedagogical mediation, everything changes. AI becomes a guided support tool. Children recognize it as a probabilistic tool, actively verifying and critically evaluating its outputs. This leads us directly to our ultimate goal, the emergence of true, critical AI literacy. Building actionable AI literacy requires us to establish explicit instructional boundaries. We must equip our students with three essential tools. First, we need to distinguish cognition. We must facilitate discussions demonstrating that AI's conversational fluency is not genuine human understanding. Second, we must explicitly teach limitations, actively exposing students to AI hallucinations, systemic bias, and the realities of probabilistic logic. Finally, we need inquiry-based practice. We must design activities that demand collaborative exploration, rigorous verification, and the constant cross-referencing of sources. To maintain an objective perspective, we must clearly interpret the boundaries of our current research. First, the study is context-bound, having been conducted within a single private school with 10 to 11-year-old students. Methodologically, we maintained a qualitative focus on meaning-making rather than measuring quantitative mastery. Additionally, the research is time-bound, representing a short-term intervention, meaning long-term developmental tracking remains unknown. Finally, it is variable-bound. We must consider that student reactions may have been partly influenced by the novelty effect of introducing a new technology. As we conclude, let's look ahead and chart the next research horizons for primary education. Our work is just beginning. Our first priority is ethical integration. We must tackle critical issues regarding data privacy, unearned trust in machines, and responsible classroom use. Second, we need to explore diverse modalities. We must conduct comparative studies involving entirely different chatbot designs and interaction methods. Finally, we must prioritize longitudinal tracking. We need multi-year studies to observe exactly how students' mental models of artificial intelligence evolve as they grow. What is the defining imperative for the future of the classroom? Our core conclusion is clear. Learning about AI is just as important as learning with AI. Interaction alone simply fosters stubborn misconceptions and unearned trust in these systems. Achieving meaningful AI literacy requires us to actively cultivate epistemic vigilance in our students. Ultimately, developmentally appropriate, teacher-guided mediation is the only true safeguard we have against technological over-reliance. The educator remains irreplaceable.
Let's dive right into this explainer. We're looking at a fascinating study. How do kids actually picture AI? Sure, kids today are total digital natives, but how do 10-year-olds actually conceptualize these complex AI systems? Well, it's all about mental models. Those internal shortcuts our brains use to explain reality. Since generative AI is basically a giant black box, younger learners are literally forced to guess how it works. In one Greek primary school study, fifth graders initially viewed the tech in a super simple way. Before any real interaction, they mostly just saw it as this magical answer-giving machine. Because of this surface-level understanding, they trusted the system blindly, without really grasping the mechanics. Then, 94 students got hands-on with a custom educational chatbot right in their regular classes. Through some trial and error, a light bulb went off. They realized they had to write much clearer prompts. They actually stopped expecting pure magic, recognizing it's a procedural system that absolutely needs their input. But here's the crazy part. These kids started forming totally contradictory hybrid mental models of the AI. They knew it was just software, but they still anthropomorphized it, calling it a teacher inside the computer. Yet in the exact same breath, they'd freely admit the chatbot wasn't a real living person. The bot's conversational fluency creates this dangerous illusion of human expertise. It completely reinforces blind trust. So this highlights a massive gap, the difference between learning with AI versus learning about it. We urgently need real AI literacy. We have to critically evaluate these tools, not just push the buttons. Kids must learn AI is probabilistic. It's essentially just guessing the next word, not spitting out guaranteed facts. True literacy means teaching epistemic vigilance, basically a healthy skepticism to spot algorithmic bias and hallucinations. We absolutely have to position AI as a collaborative tool, keep human critical thinking firmly in the loop. So, look at your own mental models. Are you just using AI, or do you truly understand it?